What's up, everybody? I will share today my progress on the art prize. I'm working on this one. So basically, this one you have to complete the letter squares. Okay, so let's get started. I'm using RunPod. And I'm using a GPU NVIDIA A40. So my model has 28 parameters. It's a transformer model with like decoder only transformer model. The training data is generated using like simulated games. And the model tries to predict the Q value of an action, like the action value predictor, like reinforcement learning. The training looks like that. So there's a few spikes that I don't like. I would like maybe to do more regularization, maybe increase dropout. I'll see that later. So what the main idea of what I do is like an action consists in changing one cell. The cell that is changed is always the one that is at the center of the visual fixation. So you can think of like the board moving, like there's some translations. And then since like if you look at a corner cell, there will be a lower number of visible cells from the whole board, so you need to do some masking, such that for a given state, all the visual fixation have roughly the same number of expected visible cells. So the training at the beginning, there's like a loss of 5. At the end, the loss is almost 0. The input of my model looks like that. There is 3 parts in the context. The initial problem, the current state with masking. The dots here means that it's outside of the board. X means that it's masked. So the neural network cannot read that, and the underscore means it's vacant. So, and like the center cell here, it's this one. So the proposed action is to put 7 there. So this puzzle has two training example and 1 test example. So I will show you the solution found by my neural network for the first training example, which should be easy because it's part of the training set. So that's a perfect solution. You can see that this 0 here became 1. And for the second example, you can see that the initial state is the blank board, like as if you would solve a real problem. So the neural network, it learned that when there's a 8 here, it must put a 8 in the output. For this one, it's also a perfect solution. Now let's look at the test example. It's almost correct. There's a missing one here. There's a missing one here. And there's a missing one here. We could argue that the neural network is pretty good with zeros because most of the time it's a 0. It's also good with 8 because there's a lot of 8. But the one, like, there's for each group of 3 8s, there's 1 1. So the neural network is less good with one. But I'm pretty happy about that, because this is what it looks like for my previous iteration. It was very bad. And maybe I can end this video just by showing you the masking thing. So you can see that like the agent is moving the board around to always position the cell that has to be changed at the center. So this is an end game, so it's almost complete. At the beginning, you can see that a lot of cells are masked, and yeah, that's pretty much it. So you can roughly see the ID here. You have a corner. Let me find it again. So this is a corner. There's 16 vacant cells. But when we look at like this one is almost like the center board. We don't see the first row. So I have to the agent will mask some of the vacant cells, such as the number of expected visible vacant cells is the same as a corner, which is 16. Seems to work well. Thank you. See you in the next video.